Hello. This doubt was posted many days back. Sorry, tough time to post the video solution. But the idea is same. You see, whenever you have a portion removed, okay, so you see, have 4 holes of radius r. These holes have been cut or removed. So this I've already told you when we did center of mass problems. Okay, so that is whenever you have this removed idea, what you have to do is you have to consider it as negative mass. Okay, so what I'm going to do is to get the moment of inertia of this remaining portion, we can consider it as one full square plate plus 4 of this what to say, circles or disc of negative mass. That's the important thing. So if I put them properly in this location, I'll get back this. So I'm going to split this remaining portion into one square plate of uniform mass plus 4 disc of negative mass, and then I have to properly find the moment of inertia. So first, the moment of inertia for a what is this, for a square plate about an axis perpendicular to the plate. For neat, you don't need it. So square plate you don't need, but yet okay. So generally you have doubts, we are discussing. So it will be like m. This is like, it's a square plate of side 4r. Okay, so this is 4r. This is 4r. Yes, this is 4 and 4. So so you see, so it is like ml square plus, let's say, length and breadth square by 12. So here both the length and breadth are 4r. Okay, so this will be like 2 times of L square. So this can be as 2L square by 12, which is L square by 6. Is it okay? So it is L square by 6, but length here L is equal to 4r. And moment of inertia for this alone I'll write. I cannot directly add because we have to make sure it's about the same axis. So moment of inertia for disk, we know it's mr square by 2. This is for a disk. Fine. So I know that this moment of inertia, I know the moment of inertia of the small disk, but when I add, you have to make sure that it is all of the moment of inertia are about the same axis. Now you see, this mr square by 2 is about their own center. But this moment of inertia about for the square lamina is about this point, about this center. So there are different points. I cannot directly add them. So what I should do is I have to first find the moment of inertia about this point. Okay, so what I should do, I have to use mr square by 2. It's negative mass. I'll substitute that later. Mr square by 2 plus m into d square, parallel axis theorem. This and this. And you see what is the parallel distance here? This is the distance. All of them will have same. So I finally multiply with the 4. D is this. Okay, and D we can find. Okay, because this is radius. You see this diagonal radius, we can do it. But first, I have to find the mass. Now, how do you find the mass? We've done this many a times. So it's a square plate, circular disc. So it is 2-dimensional. In 2-dimension, we take area and mass. Okay, so the area they have given is a side square. So it is 4r square. Side square is the area and the mass is capital M. The area I am looking for is pi r square. Radius is r, pi r square. Their mass is 2 m. As usual, we will divide and equate or cross multiply and equate. So this will be 16 r square small m is equal to pi r square capital M. We lose the r square term. So small m is pi over 16 capital M. Okay. So now I have the small m part. Again, mass is negative. So still this part will be negative, minus md square. Mass is negative. D I have to find. Now see, D is the distance from this point to this point. We can do it in multiple ways. You see, you can just convert this like this. This is r and this distance is r. So this will be r root 2. Okay, so this is r, this is r. So D is r root 2. I hope that it's clear. Now all I have to do is substitute. So finally, the net moment of inertia of the remaining portion is equal to capital M L square. L is 4r the whole square by 6 plus all of them are negative masses. Negative masses. Maybe I'll take the one second. I'll take minus 4m out. Okay, so minus m and 4 if I take out, minus 4 small m r square by 2 minus d square. Okay, let's do it slowly. So this is 16 capital M capital R square by 6 minus, this is 4m, small m is pi over 16 capital M. This is r square by 2 and d is r root 2. So this r square by 2 minus r root 2 the whole square. So r square into 2. So this is minus 3. So this gives me a a negative term again. So this will give me, let's say 8 by 3 mr square minus m pi by 4. And this will give me minus 3r square by 2. The moment of inertia term. So what I'm having is, it is the moment of inertia of this part, 8 by 3, and then this is 2. No, something is wrong. I can't get a more than moment of inertia. I can't get a plus because logically moment of inertia should be less than the part they have removed. Okay, because mass is less now. Something I've missed. Oh yeah. You see, I took a minus out. So minus out means this is plus. Okay, so this will give me not 3, 5 mr square by 2, which is positive. Okay, sorry about that. So it is 5r square by 2. Okay, that's it. Now I just had to pick mr square. Okay, so I take mr square out. It is 8 by 3 mr square out. So it is 5 pi by 8. So mr square out, 8 by 3 minus 5 pi square by 8. Okay, so I have 8 by 3 minus 5. Okay, this is it. But for some reason they have kept it as 10 by 16. The same, 5 by 8 is 10 by 16. So this, if I want, I can write as mr square 8 by 3 minus, multiply with the 2, 10 pi by 16. I hope this is clear. Okay, moment of inertia. If you have any doubts, you inform me in the Telegram channel. Those who are new to the channel, if you like the videos, hit the like button, subscribe, join the Telegram channel, linked in the description, to get video solutions for your doubts and have discussions. Watch the videos, complete videos to prepare for your NEET. All the best.